I've heard some people describe this as ABC logic, but not anyone. So show that A implies B. And B implies C. Okay, so these two together imply that A implies C. Yeah, so this is a slightly different form than the other problems where we were showing two statements equal. Now it seems like we're showing a statement. So I guess to clarify, we're showing that this statement is true. So this is true as a statement. So remember, to show that something like this is true just means that so an implication will only output false if the first thing is true and the second thing is false. So all we need to show is that whenever the second thing is false, this thing, the first thing will not be true. And then we've eliminated the only way it could be false. So therefore it must be true. I guess there's other ways to do this, but that seems like the simplest. And if you're very, very observant, you'll notice that that's actually like proving the contrapositive. Anyway, so I guess you should have paused at some point to think about this on your own, and not have me show you everything. So A implies C is false only if A is true and C is false. Okay, that's the only way that could happen. So if A is true and C is false, okay, so we have now we consider true implies B is false. Okay, so that's what the left hand part of this implication is. And okay, both these things have to be true. So we just have to show that one of these cannot be true, and we'll be done. Now, so if T implies B is true, or actually it might be easier to say if B implies false is true, then actually there was another exercise, therefore not B is true. Okay, so if not B is true, then B is false. So now we get our conclusion. So true implies B, which we said is false. So true implies false is false. Yeah, so if this one is true, then this one must be false. And if this one's false, then the whole thing's false. So the whole thing must be false. And we are done. Okay. Implication is transitive. So, and it justifies the arrow because now you can connect the arrows. So if you have A to B and B to C, then connecting two arrows will give you another arrow directly from A to C. It's kind of what it's saying. And we have an arrow here, and it's certainly we can't put an equal sign here because A could imply C, but you might not be able to get to it through B. So it's not necessarily, the converse is not necessarily true. Maybe you can think of a situation where, so the question is converse true? And for the converse to be true, we only need to consider the case when, so the converse is A implies C implies A implies B and B implies C. So that's the converse. And I mean, to test that this is true or not, we just have to consider what happens if this is true, okay? Because if it's false, then the implication is automatically true. So if it's true, so A implies C is true. The question is, can we think of a B such that this is false? And I think so, because so this could be true for any number of reasons. It could be true because A is false. And if that's the case, then we just need to think of a situation. We can even be free, or even free to choose C. So like suppose A is false. Okay. Then we're basically free to choose C because false implies C will be true for any C, and we get to choose a B, and we want to choose it so that this statement is false, and then we've proven that the converse is sometimes false. Okay. Okay. So if A is false, then A implies B is true. So this statement is just true and something. Maybe we should have done an exercise like that, but true and something is just the same as that something because the true doesn't do anything. And then the question is, can we find an example where B implies C is not true? So let me write this out. So if A equals false, then A implies B equals true for any B. So A implies B combined with B implies C is just equal to B implies C. And B implies C can be false. When B equals true and C equals false. Yeah, so there you have it. The converse is not always true, and the counterexample is when A equals false, B equals true, and C equals false. That's one way to show the converse is not true.